Okay, so it's about counting factors. So like I said, we've got to pay attention to what they're saying step by step and not think of it as separate questions. So don't, even the early easy questions, think, right, what are they telling me? So the first bit, just write down in ascending order the factors of 16. So nice and easy one, really. So 1 times 16, 2 times 8, and then 4. So we've got our... So that question is really just getting you to think about factors. Do you understand what factors are? All right? So that's part of it. Said, write down the 5 factors of 16 as powers of 2. So it's there to help you. 2 to the power of 0 is 1, so they've given you that. 2 to the power of 4 is 16, they've given you that. So now you just have to think, all right, okay, 2 is 2 to the power of 1, 4 is 2 to the power of 2, and 8 is 2 to the power of 3. Now, every time I answer a question, I look at it and think, what are they showing me? And I'm just kind of going, okay, 0, 1, 2, 3, 4. Okay, I'm just picking up these little things every time. Write down the 4 factors of 27 as a power of 3. So I might automatically go, well, that's going to be 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, and 3 to the power of 3. And it follows this pattern. Now I would then check and go, all right, is that going to be true? So 3 to the power of 3 is 27. I can check that on my calculator. 3 to the power of 2 is 9, and 9 times 3 is... So we're okay. So I've used the pattern that I spotted, but then I've checked it with something else. So we're still in the easy phase. Now, the next bit. P is a prime number. What's important about it being a prime number? Yeah, so there's no other hidden factors in there at the moment. Prime number, there's, you know, if you're looking at the factors, there's no other extra factors that every other number has. So we're looking at it and go, p to the power of 5, 6 factors. Well, what do we think is going to happen? It's just going to be p to the power of 0, p to the power of 1, p to the power of 2, p to the power of 3, p to the power of 4, p to the power of 5. We're following what they're saying. And we say, does it make sense? So p to the power of 0 is going to be 1. 1 times p to the power of 5 is p to the power of 5. Fine. P to the power of 1 times p to the power of 4 is p to the power of 5. So on. So I'm checking, but I've used what I think is happening, following it through. Why do you think they've gone from 2 to the power of, 3 to the power of, to p to the power of? What do you think the reason is for that? Why do we use algebra? Why do we use unknown letters?
To solve them.
Well, if we didn't have algebra, we wouldn't need to solve equations. So, what's the reason of putting a letter? What does it represent? Say again?
It can be different numbers.
So it can be different numbers. So we're saying we use a p to represent any number. So what we're saying is, how many factors, if p is a prime number, I can pick it, how many factors does 13 to the power of 5 have? 6. How many factors does 31 to the power of 5 have? 6. So on. So that's what we're looking at. P is a prime number. If you have that number to the power of 5, it will have 6 factors, because there's no other hidden ones in there. Right? So you see what they're doing. Write down in terms of the number of factors of p to the power of n. So if it's p to the power of 5 has 6 factors, what do you think?
And minus 1. It's plus.
Plus 1, no? Because if it's p to the power of 5 has 6 factors,
It's 5 plus 1.
so 5 and 6, so if it's p to the power of n, we've got n plus 1 factors, we think. So if n is 5, 6 factors. If it's p to the power of 8, it has how many factors? P to the power of 8 has 9 factors. So we've got n plus 1 factors. Is that all making sense so far? Can you see how it's leading you through step by step? Gets trickier. Right. 5 to the power of something, right? And how many factors, therefore, does it have?
I feel like this is wrong.
Well, what do we need to know? We need to know what the n is, because then we can do n plus 1 for the number of factors, no?
Yeah.
Okay, how do we find out what the n is?
You just factor of elimination.
Yeah, at the moment you can. I'm going to tell you that you will eventually have a different method. So maybe you want to start this for future reference, and you can solve using logarithms. Okay, so you won't know now because we haven't done it, but I would say log to the base 5 of 78125 will give you the value of n. So just to introduce, yeah, you will need your calculator. Have you got your calculators with you? Trial and error is what I would expect you to do at the moment, but let's just introduce you to logarithms just to start. So logarithms are like the opposite of doing powers. Okay. So on your calculator, you'll see down this left-hand side a 10 to the power of x, and above it is a log. So if you press Control and log, you'll see the boxes available. If you put 5, base 5, and then up in the brackets you put 78125. If you press enter, you get the answer 7. Right?
Well, guys, we were way off.
Now, what you would have done is go 5 to the power of 1 is 5, 5 squared is 25, 5 to the power of 3 is 125, 5 to the power of 5 is what? Still too small. 5 to the power of 6 is what? Still too small. 5 to the power of 7 is what? Oh, it's that. Good. Right? So we know that 5 to the power of 7 is 78125. So you could have used your trial and error method, which is what I would have expected you to do at this stage. Later on, you can solve using logarithms. Right? So that means if it's 5 to the power of 7, how many factors are there?
8.
8. So we have 8 factors. Okay. Make sense? Okay. So there's the simple case, prime numbers. Now look at the next page. What have they introduced? Well, 20 is not a prime number. So we're going, as if you were going to do your own investigation, which you don't have to do anymore. That's why we have these papers in Cambridge exams. You would go a step further. So you would start your investigation off with the simple case. How many factors does a prime number to the power of whatever have? But of course, if it's not a prime number, we've got a different issue, which is, like for instance, they're telling you 20 is not a prime number. Therefore, 20 can be made by doing 2 times 5. 2 to the power of something times 5 to the power of something. So we've got that split up, right? And they give you a table to work out, because the table is all important for how you go next. So we have to look at it and not just answer the questions, but look at what they're trying to tell us. So we've got 2 to the power of 0, 1 times 1, right? 2 squared is 4 times 1 is 4. We go 2 to the power of 0 is 1, 5 to the power of 1 is 5, so that's 5. 2 times 5 is 10. And the last one's done for you. What do you notice about the table? Say it again. Louder.
In order.
It's in order. So I've got 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. 5, 0, 0, 0. But then we go again. 2 to the power of 0, 1, 2, but this time it's 5 to the power of 1. Why have we not got a third column with 5 to the power of 2? Pardon? It wouldn't equal 20. 5 to the power of 2 is already 25, so you haven't got 2 to the power of anything. So we look at that and go, right, there's a pattern there. I've done 2 to the power of everything with 5 to the power of 0, and then 5 to the power of 1, and I figured out that's all my factors. Alright? Now it again leads you with, the table has 3 rows and 2 columns. How do you find the number of factors of 20 from the number of rows and the number of columns? How many factors are there? 6 factors. 1, 2, 4, 5, 10, 20. What do you notice? How many rows? How many columns? 2 times 3. So we write rows times columns. Easy question, but they're getting you to think it through. You know, that's how they're doing step by step there. That is not a throwaway easy question. It's not just it's like spot it. Notice what we're doing. All right. Why do you think? Why, for instance, this is where you need to start thinking about the question. Why are there 3 rows? So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. So that 2 tells you how many rows you're going to have, and the number of columns is how many powers of 5 you're going to have. Does that make sense? So the next question then is find the number of factors of 400. So notice how we have 2 and 5, 2 to the power of 5 times 5 cubed. So how many rows will there be? 6, because it will be 2 to the power of 0, 2 to the power of 1, up to, so it will be 6 rows times 4 columns will be 24 factors. Okay. Right. So here's the how much do you understand the bit? It starts getting tricky. So we've got 1,000,000 is 2 to the power of something times 5 to the power of something. Find n. So what do we do?
2 times 5 is 2. And then you see that has 6 rows. So you just put 2.
Okay, I'd go with that. 2 times 5 is 10. 10 to the power of what? 6. 10 to the power of 6 makes that.
So n is 6?
No.
No.
No, sorry. Yes. Not what I'm thinking of a different question. So that means we've got 2 to the power of 6 times 5 to the power of 6 makes the 1,000,000. So yeah, n is 6. I'm thinking of a different question. N is 6. Alright? Are you happy with that? Okay, I'm thinking of the next thing. How many factors of 1,000,000 are there? So 6 add 1 times 6 add 1 is 49. Okay, so there are 49 factors. Happy with that? Can you see how it's building up step by step? Right. Find n such that 10 to the power of n has 900 factors. Well, I've got to work backwards. So for instance, remember if there are 49 factors, rows plus 1 times column plus 1 multiplied together makes the 49. So I'm looking for something times something makes 900. 30. So it's 30 times 30, but then that leaves 2 to the power of what times 5 to the power of what? What would it be? If it's 30 times 30, it'd be 29. Okay. So n is 29.
Well, I was way off.
Yeah? You can be completely way off, no problem whatsoever. If you haven't grasped what they're doing and you're not following it step by step, I think once you tune in to what they're leading you through, it becomes easy. If you can't tune in to the way they're doing this particular problem, it'll become impossible. All right? Now, this last page is the hard one for me. Yeah, this is where I took a few minutes on each question to think it through. All right? So, for instance, x has two prime factors, 3 to the power of 7. Sorry, 3 and 7. So 3 to the power of something times n to the power of something. And it has 12 factors. Alright? Find all possible values of x that have 12 factors. So what I'm thinking is, does anyone already have an idea? No idea? You can't think of the process that we've been trying to do? What do we know about if it has 12 factors? What?
Oh, it's 13.
Then it's
Think
11.
rows and columns.
11.
So
Which is power of 11.
It's not yet. Don't think about that's the power, but what do we have to do to get the number of factors? We have to multiply those two together. So remember it's the rows times the columns that give me the number of factors, yeah? Go right back to the beginning. And you might need to do this. When you get to a question, right, I need to go back to the beginning of this section. And so I know, for instance, that to get 12 factors, the rows times the columns have to be 12, yeah? Therefore, potentially, there could be one row and 12 columns. There could be 12 rows and one column. There could be 2 and 6, 3 and 4, 4 and 3, 6 and 2. That's the number of columns. Does that make sense? Now, I've not done anything yet. I've just looked at it and gone, right, that means my options could be 3 to the power of 1 times 7 to the power of 12. Before you write this down, because you're just writing with no thinking at the moment, is that an option? Am I right? What I've written? Because you are just writing without thinking. What I've done one thing wrong here.
It's supposed to be 1 times 12. You put the powers in that. It's 1 times 7. Access is actually 2.
What's the link between the rows and the powers? What? I think you said it. Don't add the powers, we definitely multiply the powers, but what do we add? 1. The powers are 1 less than the rows, aren't they?
So you have to.
So it should be
11.
0 and 11, which I think Bianca was half 11, 10, 11. However, there's another problem with this, which is, it says, has 2 prime factors. Are both of those prime factors?
Yes.
What's 3 to the power of 0?
1.
Is 1 a prime factor?
Yes.
No. 1 is not a prime number. So that means 3 to the power of 0, which would be this row, that one doesn't give me anything that I want. So I have to get rid of that one. So I'm going to forget that line. Well, that also means that this one, because this would be 7 to the power of 0, yeah? So that line's got to go. So that leaves me with 3 to the power of 1 times 7 to the power of 5. 3 to the power of 2 times 7 to the power of 3 to the power of 3 times 7 to the power of 2, and then 3 to the power of 5 times 7 to the power of 1. Now, got to read the question. You lose marks if you only answer it like that. What we've got to do is find the possible values. So we've actually got to work those out. So what are those values? You have to put them into your calculator. And you do that for me. Or for you, do it for yourself. Okay. Oh, this was just a little test to see who's just writing down my answers and who's doing them themselves. Because I could see on the faces of the people that did themselves that I've written down completely wrong numbers.
Well, I have to write it down.
Had me started.
Yes. No, well that's what I realised for a couple of people. So I thought I would just have a bit of fun and write down completely wrong answers. So this one, for instance, we know should be 308. 7. This one, 1, 3, 2, 3. 1701. Okay.
That's funny.
So I looked, and some people, Alexandra's face was a picture.
I went like this.
She's going to write down, and she tapped in a calculator again. She couldn't decide between writing down what I'd written or writing down what she knew was the right answer. So always write down what you think is the right answer and then question me. Don't just write down what I've put on the board. Okay? So we've got those. Now we've got the final questions. They're the ones that are going to challenge your understanding. All right? So 336 in the form where we've got 3 prime factors this time. This is actually a quite simple question. You all know how to do it? You remember how to find prime factors?
I did 1, 3, 5, and 7. And then I
1's not a prime number. And that's 4. But 3, 5 and 7 might work, yeah?
Yeah.
Do you remember your prime factor trees?
Oh, it's funny.
3 times 1, 1, 2. So 3 is a prime number. 1, 1, 2, I would say 2 times 56. Then I would go, actually I know that it's 8 times 7, so 7's a prime number, and 8, actually I'm just going to do my shortcut. 8 is 2 cubed, which is prime factor. Are you happy with what I did there? So I've kind of used a more, rather than do it all, so that leaves me with 2 to the power of 4 times 3 times 7. Okay? That's fine. Yeah. Actually, for the next bit it helps if you've put 3 to the power of 1, 7 to the power. You're not penalised for doing it. Now, really, for part B, what we're doing is we're taking a bit of a leap of trust in ourselves. We can check, and we're looking at, well, this is where they've led me, this is what they want me to do. I'm going to assume that this carries on working, and we can always check. So it says find the number of factors of 336. So what did we do before when we had two parts? We know the powers. What did we do to find the number of factors? Add 1 and times them. Might it work here?
Maybe.
So what about 5 times 2 times 2, which is why it might help if you had the 1. Okay, so 4 plus 1, 1 plus 1, 1 plus 1 gives me an answer of 20 factors, and it is actually correct. You might say, well, how am I going to check that? Well, up to you. You can try and work. It's going to take you a long time. This is the whole point of investigations, getting to a point where you've got a number like this. Are you happy with that one? No? What's up then?
Why is it 5 times 2 times 2?
Because remember, we take the powers We add 1 to the powers, and then we multiply them together. Yeah? So we used what we did with 2 numbers, where you've got rows and columns. Obviously the rows and the columns don't really work now because you've got 3. But we kind of just, we've looked at this and that seemed to work. So,
It's really not even cool.
okay, so we've got to answer this final question. So a number has exactly 3 prime factors, 2, 3 and 5. Has 12 factors. So we have to kind of use everything at this stage, everything that we know. So we know it's 2 to the power of something, I'm going to say m, okay, times 3 to the power of n times 5 to the power of p. Right? I didn't use O because it looks like a 0. How do I do it? Well, I know that m plus 1 times n plus 1 times p plus 1 has to equal 12. Now you might think, well, that looks overly complicated. We don't need to worry about that. We just need to find the numbers that multiply to make 12, 3 of them.
Multiply to make 12.
So what numbers multiply to make 12?
6.
So 2 and 6.
4 and 3.
Okay. But we need to make 3 numbers out of that. So if I said 2 times 6, but instead of 6 I write
3.
2 and 3. Okay, that makes 12. Is there anything else? 1, 3 and
4. We could do 1, 6 and 2.
That's kind of it really, isn't it? However, we've then got to look at the fact, well, we want n plus 1. And anywhere I've got a 1, do you remember the problem with that? It became something to the power of 0, because we've got to take 1 away from these numbers, haven't we? And we're not using the something to the power of 0 because that leaves 1, which is not what we want, yeah? So that means basically these 2 options are a bit defunct. We can't use them. So that leaves me only with the 2, 2, 3. And what do we need to do with the 2, 2 and 3? We need to find the powers. So for instance, it would be 2 to the power of 1 times 3 to the power of 1 times 5 to the power of 2. So we've done the, you know, up here we had to add 1 to get the numbers to make the factors. We're doing it in reverse. So we know how many factors, so we've got to figure out what the powers are. Does that make sense? Okay.
How do you get the 2?
How do I get the what? Because 1 minus 1 is 1, 2 minus 1 is, sorry, 2 minus 1 is 1, 2 minus 1 is 1, 3 minus 1 is 2.
Okay.
Now, what do we know actually about 2 times 2 times 3? Can be it equals 12, and does it matter what order it's in to equal 12? No, so what, could I write the 3 there or the 3 there? So that kind of makes me think, well, what about 2 to the power of 1 times 3 to the power of 2 times 5 to the power of 1? They all add 1 and multiply to make 12, so that works, yeah? And then the final option will be 2 to the power of 2 times 3 to the power of 1 times 5 to the power of 1. Remember, we should always check, what do I know? Well, this investigation has all been about take the powers, add 1, multiply them together, get the number of factors. Does that make sense? So we're just checking, am I still abiding by that? Take the powers, add 1 to them all, multiply, tells me the number of factors. So 2 times 2 times 3 does make the 12. Right? Doesn't matter what order they're in. Are you happy with that? So what we actually want is find all the numbers, so we need these values then. those values are, you can do them in our heads now. 2 times 3 times 25.
Maybe not.
75 times 2.
Yeah, 75 times 2 is 150. This one's 90. 9 times 2 times 5
60.
is 9. And then this one's 60. Okay, so there are 3 numbers. So I have to say I had to sit and think, because I kept on losing track of the whole, it's the powers, add 1, multiply them. But as soon as I got that in my head, and now I go through it again, second time, I'm like, yeah, actually that's all easy, that makes sense. But if, while you're doing it, you lose track, it can be tricky to follow it. Alright? But that's why we practice. We have to practice. If you don't practice, you won't get in the habit of following step by step. That's why I say we have to do these regularly. There'll be other problems. There'll be different situations. Remember the first one we did? Remember that first one I set for homework? Which we haven't been through because didn't necessarily see the point. Do you remember it was triples? You've got some nice easy things to start with. You know, find the pattern, they lead you through the pattern. Again, different problem, same technique. So we need to practice the technique. That's why I say revision for paper 6 is not about the revision of the topics necessarily. It's simple maths. It's about noticing what's happening. Right, just to take you through the mark scheme then. All right, just to show you there's an important thing. So, maybe you want to give yourself a score then. So if you got the 248 right, 1 mark. If you got the powers right, 1 mark. 1 mark for the next bit. 1, 2, 3, 4, 5, 1 mark. N plus 1, 1 mark. 8, 1 mark. This is the bit I want to point out to you.
What is C?
C is communication. For investigations, there is an extra mark in each section for communication. So, for instance, if for this question, so what was it? Question 2.
B. That's what we all guessed.
Yeah. So if I only wrote down the number 8, I don't get a C opportunity. You'll understand more about C opportunity. So if I'd have written something like, here's my working out, this is what I've done logarithms, I've written out that, or if I'd have written trial and error and I'd written 5 to the power of something is this, 6, right? Remember, you're not just solving a problem, you're doing an investigation. That's why they say they expect to see it. So if you wrote some stuff out for this question, I would say, okay, not a mark yet. I would just say there's a tick for some communication on that particular question. All right? So if you think you communicated well, give yourself a tick, a C. Write a C next to it if you like. Obviously, if you didn't do it. Question 3, the whole table, all the values, 1 mark.
Oh, these people are mean. Stingy people.
Multiply. Rows times column, have to multiply. 1 mark.
1 mark.
Yeah, just multiply. Again, notice how there's a C opportunity again. How did you work it out? So you might notice here, look, I did 6 times 4 is 24. I would give myself the communication mark. Right?
So it's like an FT mark. Or not.
6, 1 mark, 49 follow through, because if you did 5 for instance, you'd have an answer of 36 because you add 1 and multiply. Right? So you got 10 to the power of 5. Again, there are 2 C opportunities for A part 2. Right? Why is that, do you think? Now, I would give myself both, because I did 6 add 1 both times to show I'm taking the 6, I'm adding 1, and I'm multiplying to make 49. If I'd have only written 7 times 7, I'd have got one of the two. If I've only written 49, I get no communication. Does that make sense? Okay. 4 possible answers, 3 marks. 2 marks if you wrote 3 of them, 1 mark for 2 or 1. Right? If you don't get any marks, but you do write these bits, you get 2 marks and so on with no extras. Again, another C opportunity, another chance to show some communication. So question 5, you'll notice, look what I wrote.
Yeah.
For all of this, I would give myself my C opportunity. Now, if I had, for instance, not written those answers and just done that, I'd get 2 marks, as long as I didn't put these extra ones in. So the fact that I've crossed them out, but because
You wrote it.
I wrote them everything out, I get my C opportunities. If you don't write that out, you just write the answers. Okay, you get the 3 marks for correct answers, but you'd lose out on the C opportunity. So get this difference between there are no longer method marks to get the answers, but there's communication chances. All right. 1 mark depending on whether you got these right. Again, a C opportunity if you put the working out. Again, C opportunity. Now,
7 is worth 2 marks.
7's worth 2 marks for those 3 answers. Now look, it says for the final mark, so you have to show communication in 3 of the following. So if at any of these opportunities where it said C opportunities, you have to have done it 3 times. For this one, it changes all the time. It might be you only have to show it in 1 of them or 2 of them, or but it depends. You will not know. You just have to show as much communication as possible. So I would go through, for instance, and I would write, oh yeah, C, C, C. If I only give you 2 C's, no mark, no extra mark. So that's the thing. So how many marks are there in total then? So 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20. So if you do no communication whatsoever, you can't have 20 marks. Simple as that. You only get 19 out of 20 for this part. And we have the same thing for part B. Again, there's communication marks. All right?